Now, last but not least, before we stop our class, okay, I need to discuss exercise 4.1 so that I can make sure that everyone is okay with this particular topic. Okay, class, let us look at exercise 4.1, okay, on page 125. So, lifetime of 4 brands of battery is to be compared by testing each brand in television remote controllers. Okay, so you have 20 TV remote controllers and are randomly selected, and each battery brand is put into 5 TV remote controllers. Okay, the lifetime of batteries to the nearest hour are as follows. So you have brand A, B, C, and D. And you are talking about the lifetime of this particular battery, depending on the brand. Okay, so identify the dependent variable and factor in this problem. Now, this one I want someone to let me know. Okay, class? Now, what is our dependent variable? Dependent variable, class? Anyone wants to try? What is our dependent variable? Or call it as response variable? Is what, class, here? Hello, try.
Lifetime of battery.
Lifetime of battery. Okay, lifetime of battery. Thank you. Now, what is your independent variable? That will be your factor. Class? Your factor, what is your factor? So this is all your response variable, your dependent variable. And this dependent variable depends on your factor. What is your factor?
Brand of battery.
Yes, brand of battery. Now, what is your, in this case, treatment of groups? What is your treatment of groups?
Brand A, brand B, brand C, brand D.
Yes, brand A, B, C, and D. What is your experimental unit? Look from the scenario.
Hour.
Huh? No. Read again. Experimental unit is the things that you use to test. What do you use in this case?
TV remote controller.
TV.
Yes, TV remote controller. Okay, so that would be your answer for each and every for terms that you have in your ANOVA. Now, calculate and compare the sample means lifetime between the 4 brands. So if I put here the average value, so X bar A is equal to 46.2. So add all divided by 5. X bar B is equal to 40. X bar C is equal to 46.4. Okay. 46.4. And then X bar D is equal to 53.6. Now, calculate and compare the mean lifetime between the 4 brands. Okay, imagine if you have calculated this on your own. Okay, how do you compare? How do you compare? Class, how do you compare?
Highest and lowest.
Okay, can. That would be the easiest one. I think the shortest code. The shortest lifetime is brandy, right?
Yeah.
Okay. And the longest lifetime is brand C.
C.
Okay, so that would be your you can compare that way. Okay, so that would be one way out on how you can compare. Or you can say you can just rank them. The first is the shortest is brandy, followed by brandy, followed by brand A, and then finally brand C, the longest time. Now, number 3, Roman. Based on comparison in two, what can you conclude? Based on two, based on calculation, not based on test. What can you conclude? Can someone try? What can you conclude? Now we are talking about equality of population mean, ANOVA. So just go back to the terms that we wish to test. Okay, so that will be easier for you to answer the given question. Based on two, what can you conclude? Right? Try. Can someone try? Okay, I'm happy that you can answer one Roman to Roman. Okay, what about 3 Roman? What can you conclude? Your conclusion is based on your observation, yeah? So there would be words that you need to show that it would be uh, the outcome, but it's not the final answer. What can you conclude? Huh? We may assume what? We may assume what, class?
Brand C have a good lifetime.
No, 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 no. What can you conclude? We are, remember class, ANOVA is not about finding which one is the best. We just want to find out whether the population mean are equal or not. Okay? So how do we answer this? We may what? Assume that all uh, what all brand A, B, C, and D have different mean. Go back to the key grassroots of your discussion. Okay, we are talking about the population mean. So comment about that particular concept. So we assume that all brand A, B, and C have different mean. Okay, mean lifetime. So just to be specific, lifetime. Okay, mean lifetime. Okay, understand class? Okay, number 3 done. Number 4, using the individual plot below, comment on the variability in the response variable within each brand of battery. Now, we have talked about the variability based on mean. So this is how we look on the variability based on the mean, sample mean. Okay, now you need to look at the plot of your data. So let us look at your data. Okay, so you have brand A, you have brand B, you have brand C, and you have brand D. Okay, now the question asks, okay, so this is how the ANOVA question will be always be asked, okay, during the assessment. So you need to faster, you need to think fast and then find your, whatever argument that you can have for your answer. Okay, comment on the variability in the response variable within each brand. So what can you say is that look at your data within the brand. So if I'm looking about brand A, brand B, okay, I think this will be much easier if I put it this way. Okay, so we can see that in terms of average, okay, it seems that brandy got the shortest lifetime. But in terms of the plot, you can see that brandy has the smallest variation, right class? So we can say here, this brandy, okay, brandy has the smallest variability, because all the data scattered near to each other. Okay, all data scattered to each other. So that will be among other things that you need to have in mind when you look at the plot. Okay, compared to B, of course, compared to A, C, and D, D would be second highest variability. Okay, because the data is almost scattered near to each other, but not as close as brand B. Compared to brand A and brand C, the variability is in fact even larger. Okay, large variability. So that's how you can comment on the variability for each of the data, group data. Okay, large variability. Any questions so far, class? Class, any question?
No.
Okay, so that will be on how you can detect or comment about the variability for each of the brand involved in your experiment. Now, preliminary data analysis indicate that the independent sample from normal population with equal standard deviation. So, this reflects the condition of your data. So, assuming that all the assumptions are fulfilled, so we can proceed with your analysis of variance. Way ANOVA. At 5% significant level, does there appear to be difference in mean lifetime between the 4 brands of batteries? So here, clearly, this is your claim. And your claim is at the alternative statement. Okay, so let us see how we can use our Excel to help us out in generating our ANOVA table. Okay, so we go to exercise. Okay, I have keyed in the data for you. You can go to your data, go to data analysis. Okay, single factor. Okay, okay. So choose your data. Okay, since I don't want to be, okay, so I want my data to be this one. So select including the brand name, so that it will appear in your what we call in your analysis afterwards. Now, since everything is in terms of column, so I click column and I click level in the first row, because I have in my first row, not this row, not this one, but this one, because we highlight from A2 until D7. So level in the first row, alpha 0.05, and my output range, I want it to be here. Okay, and then click OK. Okay, class, that's how you can generate. Now, if you did not, let me enlarge the size of the font so that it can be easy for you to see. Okay, so you can see here. Okay, if you did not put your brand name inside your data just now, you will have here as column 1, column 2, column 3, column 4. So it will be given you this way: column 1, column 2, column 3, and column 4. It will not given you the name. So if you have the name here, it will be easier for you to check. Okay, so we can see from here. Okay, this is how we get the summation of all the group summation, average of the group, variance for each group, and we have our ANOVA table generated here. Okay, let's move back to our notes just now. Okay, I have copied the Excel result for you. Can you see, class? Can you see, class?
Yes, madam.
Yeah.
Okay, thank you. So, oh, I did not copy the statement. Okay, now let us answer the question here. Okay, so I will be finished after we finish discuss the ANOVA table. So we will end our class there. So let just hang on for a while. So we start with the first step. Okay, the first step is your ANOVA statement. Null will be there is no difference. There is no difference. Okay. In the meantime, in the mean lifetime, okay, between the four batteries. Batteries brand. Okay, the alternative would be there is a difference between in the mean lifetime between the four batteries. Okay, step number 2 from our ANOVA table, we have our FCV that would be 3.2. So by now, I hope you can use your ANOVA table as well. Your F distribution table to help you out finding the F critical value. So your FCV that would be 0.05, and then you will have 3, and then 16 given by 3.3, 3.24. Your F test is equal to 7.2829. Okay, 29. Number 4, decision. I would always like to draw my F distribution, so easier for me to describe. So I have my F test is my FCV is 3.24, and this is my rejection region. Okay, and my F test, my F test is somewhere like 7.29. Okay, so falls in the rejection region. So here we can say reject null hypothesis. So our conclusion would be, what would be our conclusion? Since our claim is at the alternative, here is our claim, and we reject the null hypothesis. Is the answer correct? Okay, 7.289. So in this case, we have sufficient evidence how do we make the conclusion just now? We have sufficient evidence to support the claim. We have sufficient evidence to support the claim that, so just copy from your sentence here. Does there appear be difference in mean lifetime? So you can say the claim that there is a difference, okay, in mean lifetime, okay, between the four brands of batteries. Okay, so you can see from your ANOVA table, you are safe to reject because you have big sum of square treatment. So within the group variation is between the group variation is very high as compared to your within group variation. In fact, your within group variation is considered also high. So that's why you have very small f. Imagine if you have smaller between group variation than your within group variation. So you will have very small f and it will be difficult for you to reject the hypothesis. So for class, do you have any questions for the exercise?